Good morning, Year 10, and welcome to your first lesson. Ultimately, we are going to be going through paper 1, physics, starting with topic 1, all about energies and energy transfers. So the first lesson today then is energy stores and energy transfers. And the first thing I want you to think about is what type of energy stores are there? So have a look at this. This is a little story. I want you to think, what are the energy stores that are mentioned here in the story? So I wake up, I jump out of bed, I run down the stairs to make breakfast, I eat my cereal, then I get ready for school. I get in the shower, I put on all my clothes, I'm running late, so I run for the bus and I just make it. So what types of energy do you think I'm talking about here? So how did you do thinking about that? So when you think about what's happening when you jump out of bed and you run down the stairs, you are ultimately taking the chemical energy stored from what you ate before you went to bed and transferring that into the kinetic energy that you need to jump out of the bed and run down the stairs. And by going down the stairs, you've got gravitational potential energy pulling you down the stairs and allowing you to move down the stairs. When you eat your cereal, again, you are now then refilling your chemical energy. When you get in the shower, okay, unless you're a bit strange, you're hopefully having some thermal energy because the heat from the water. You then put your clothes on, again, kinetic energy as you're moving your body to put those clothes on. You're running late, you run for the bus, again, more kinetic energy. If you're running, you may produce thermal energy as well because you may be sweating. So it's all about energy stores and how we transfer them. That's what we're going to be looking at in today's lesson. Okay, so first task is to identify the energy stores. Makes sense. So here they are: kinetic, thermal, chemical, gravitational potential, or GPE, elastic potential, electrostatic, magnetic, and nuclear. So have a think about these. They have an energy store and they have a description. All you need to do is match them up, please. So make your notes either on in your book or on a Word document, however you want to, because we will be asking to see some of this work at some point. So please make sure you're making notes as you go along. First thing you need to do, get your energy store and get the right description for it, okay? Don't forget, you might need to pause the video here while you complete the work, because the answers will be coming up on the next slide. Okay, Year 10, it's time to mark your work and see whether you got these right. So kinetic energy is anything that is moving, okay? It stores a type of energy in it. Thermal energy is all objects store this energy. The hotter they are, the more of this energy they have. Chemical energy is anything that can release energy. So food, fuels, anything that has a chemical reaction. Gravitational potential energy is anything that has mass and inside a gravitational field. Your elastic potential, anything that is stretched or compressed. Your electrostatic is anything to do with electric charges and how they are attracting or repelling each other. Your magnetic is anything with a magnetic field where it's interacting, so two magnets that are attracting each other. Nuclear is the nucleus of an atom, obviously giving out energy as it's breaking down. So these are the ones that you need to know, and it's really important that you can recognise how one can transfer into another. That's what we're going to look at in the next few slides. Okay, so now we know the different types of energy stores, we need to look at what energy transfers are. So energy transfers take place from one energy store to another. Energy cannot be destroyed or created. That is the conservation law. There's different ways, though, that energy can be transferred, and you need to know these 4 types. So the 4 main ones are mechanically. Now this is a change due to a force acting on it. So a push or a pull, a stretching or a squishing. Okay, that's a mechanical transfer. An electrical transfer, electrically, changes due to the current flowing through the different devices in a circuit. There's a thermal, or by heating, that's the changes due to the objects getting hotter or colder and transferring its energy from one place to another. And there's radiation, which is where energy transfers through waves. Light and sound is an example of this. You need to be able to identify not only the store and the energy transfer, but how it is transferring. Is it mechanically, electrically, by thermal or radiation? So, next task for you then is to complete these activities. So, I've given you an example, okay, of a type of energy transfer. So we've got a kettle with boiling water. Its initial energy store is electrostatic, okay. The energy transfer is the electrical energy goes to the kettle, yeah, from the plug going to there, and the heating of the element, okay, so that heats up the water. So the final energy store then is thermal. We've got electrostatic energy or electrical energy turning to thermal energy. That's the transfer. So there's some more examples here: car on a ramp, candle, light bulb, rubbing your hands together, and a wind-up toy. What I want you to do is pause the video for a bit, write down the table, and see if you can identify the initial energy store, the type of transfer, so out of those four that we just mentioned, and what the final energy store will be. Remember, sometimes there may be more than one initial energy store, and there may be more than one final energy store. So have a think about what's happening, and remember to pause the video so that you can complete the work, because as I said before, the answers are coming up on the next slide. So, time to mark. How did you get on? So let's have a look at the car. The car, obviously, if it's on a ramp, will have gravitational potential energy. So at the top of the ramp, it has that ability to move down. It's mechanically being transferred because the car weight is acting downwards on it. And then the final store will be kinetic because it will then move down the ramp. With a candle, the wax in the wick itself have chemical energy. And the energy transfer is by heating and radiation. Heating and radiation come together quite a lot. The final store then is thermal energy to its surroundings. There's also light energy as well. The light bulb has electrostatic, okay, because it's a light bulb and it's being powered by electricity. The energy transfer is then electrical to the bulb and by radiation out of the bulb, because remember there's going to be some thermal and some light. The final store then is the thermal energy to the surroundings, and also there will be light energy as well. When you rub your hands together, you've got chemical energy, and this is a difficult one. Sometimes people forget that they've got chemical energy in their body because you've eaten food, and the chemical energy is stored then in your muscles. So when you're rubbing your hands together, your muscles are the ones that are doing the work. Also, you could have said there's some kinetic energy because you're moving your hands back and forth. The energy transfer is mechanical because you're putting two forces. You're pushing your hands against each other. And your final energy then is thermal energy. Your hands get nice and warm and toasty. With a wind-up toy, you've got your elastic potential energy when you wind it up. And then it's a mechanical transfer because we're changing with a force. And hopefully it's kinetic energy as the wind-up toy will then move. So well done if you got them right. If you didn't, make sure you make your corrections and try and understand why those energy transfers. Because at some point we're going to be looking at how you would draw diagrams to show those in your exams. So now we've introduced you to types of energies and the energy transfers. There's a worksheet attached with this lesson. What I would like you to do is to complete it. Now you can either do it on the worksheet, take a picture of it, send it to us. You can write down the answers and email that to us. You can do it on Word, PowerPoint, however you can. That would be great. Okay, but please either send it to myself, mhoney@knoleacademy.org, or to Miss Nixon at knixon@knoleacademy.org. We're going to be using the submitted work to monitor the attendance to these online sessions. So please make sure you send us your work. If you have any issues, just let us know, get in contact, and we can help you. Okay. We have sent out some information with the lessons to say how you can get extra data on your phone if you need to. And again, if you can't print out worksheets and you can't do that from home, it's not a problem. You can just write it however is easiest for you to send it to us. Okay, but we're really looking forward to seeing some work and having something to sort of assess how you're getting on. So please do send it to us. Okay, it's really important. Thanks. Speak to you soon. Bye.